Hello everyone, my name is Rima Dennis. Welcome to my YouTube channel. Thanks for the subscription. I'm a student at Moon University. Presenting to you a very important concept in operating systems. Many of you have been wondering how is memory managed in operating systems. Here I am to actually elaborate and explain in detail what memory management actually refers to. Before we proceed, let us first actually define the term memory. In layman's language, the term memory is actually just a store of data, either temporarily or permanently. Here it has been defined in a technical manner, as you can all see. Memory management is the process of controlling the allocation of resources to the instructions being executed by the computer or by the CPU. It ensures that instructions that require resources are actually serviced or served to enhance user experience. Yes, these are very important terms in memory management. We have the logical and physical address map, the contiguous memory allocation. The term logical is actually refers to virtual memory, and the term physical is the tangible memory. Okay, contiguous memory allocation is the systematic arrangement of memory addresses, one-on-one memory the orderly arrangement of memory stores. Logical is actually virtual, and physical is the memory where we store our data permanently. In logical, data is stored temporarily during the execution of these processes to allow swapping and to service interrupts. Okay, it's generated by the CPU while the program is running. Physical address is actual location inside the main memory. Let us actually move to the next slide. Fixed and variable partition, internal and external fragmentation, compaction. We have this line, fixed and variable partition. Okay, this has been integrated into one, and internal and external fragmentation also has been integrated into one. Actually, physical fixed partition creates partitions or creates memory in identical sizes. You may find, for example, in a store, let me say a store where you keep your items. You have a partition where you store your utensils. You have a partition where you store your jerry cans. You have a partition where you store your charcoal. You ensure that each and every item gets an equal share. This is what we call fixed partitioning. Variable partition, you actually inherits some logic while partitioning this. Partitioning this store, you may find that charcoal may not actually require the same space as the jerry cans or as the utensils. So the space for the charcoal will be made actually much more larger compared to the space for the utensils or the cups or what and so on. What is internal fragmentation? The difference between internal fragmentation is just the difference between the demanded memory by a process and the memory which has been allocated by the process. In normal circumstances, actually, the memory which has been allocated to the process is actually larger to the memory which it demands. External fragmentation has empty blocks scattered all over, which are insufficient to be allocated to other programs, only to answer allocation requests. We actually have some, in external fragmentation, we have some let me say residue stores. These residue stores are, the residue partitions are there, of course, but they are not enough to be taken up by processes, to store processes. They can only handle requests. Okay, let us go to compaction. Compaction is a process where the memory manager rearranges the memory space to create larger blocks of contiguous memory. You might find that the memory has been scattered. You might find like this partition is this side partition and left, this partition is in the center. So contiguous memory, as I have explained earlier or recently, contiguous memory allows us to arrange our partitions in an orderly manner. Let us go to the next slide. What is paging? Okay, paging is actually, in simple terms, the transfer of data between secondary and primary memory, both storage divided into fixed precise blocks, which are pages and frames respectively. Okay. Here the pages represent the physical or the main memory, and the frames represent the main memory or the physical memory, and the pages represent the virtual memory or the logical memory. Okay, this is actually like the swapping. Paging is like the swapping of the memory of the items or the processes between virtual and physical memory, or between the physical and virtual memory. What is demand paging? This is the memory which has been. This is the exact memory which has been allocated which is the exact resource which has been allocated into an instruction to a process. Exactly the exact amount of resource which has been allocated to the process as it required it. Demand paging hardware support. It requires several types of hardware support. We have higher terabyte, you see, and an address transaction mechanism. Paging allows for protection and sharing of memory as its advantage. But okay, let's move to the next slide. Even though paging is very important is a very important term in memory management, though it has some drawbacks, it has some demerits we have to discuss in this slide. We have the internal fragmentation caused on older systems. Okay, you can only do internal fragmentation on older systems, not updated systems that in the currently we are using. Okay, the memory lookup time is more in paging compared to segmentation. Paging takes more time. It actually consumes time. We have no time. Remember, we require in real-time processing, we require very fast computations, and paging cannot meet those requirements. Additional memory is consumed by page tables. Remember, you have to store the address. These are the page tables require the IP addresses of these frames or the physical addresses. Multi-level paging can cause memory reference overhead. Let us move to the next slide. Virtual memory, we have discussed it, but let us discuss it in further more details. Is a technique in OS where both hardware and software are used to enable a computer to compensate for physical memory shortages. Temporarily transferring data from random access memory to disk storage. Okay, we have discussed this, and actually virtual memory is actually occurs only when the computer is executing some programs. Support needed for virtual memory. Hardware must support paging and segmentation. We have discussed paging, we have discussed segmentation, which is partitioning. Operating system must be able to manage the movement of pages and segments between secondary and primary memory. Hardware and control structures. Locality of reference. Hardware and control structures. Okay. Let us discuss hardware briefly. And control structures are components that work together to manage system resources, handle user interactions, and provide a stable and secure environment. Also, these are the keyboards, hardware and control structures. We have the device drivers, we have the interrupt handlers, we have the memory. Okay. Locality of reference is the tendency of the processor to access the same set of memory locations repetitively over a short period of time. Like a program like a processor is actually, for it, it is programmed that you see, whenever you're executing a process in this similar manner, you must access this type of resources. This is what it actually is trying to tell us. Temporary locality as the type of locality of reference refers to the use of specific data or resources within a relatively small time duration. Okay, here it is on the side of the CPU. The CPU uses the same data or resources within a relatively small time duration. We have static locality refers to the use of data elements within relatively close storage locations. Actually, this is the vice versa of temporal locality. Here it is instead the data elements within, here the data elements within relatively close storage locations use the same resources. Okay, let us move to the next slide. Benefits of exploiting locality of reference and page fault. Reduced page faults, we have improved memory utilization, we have enhanced performance, we have page fault. Page fault, let us define page fault as an important term as well. Occurs when a program attempts to access data or code that it is in its address space but is not currently located in the system RAM. It is part of the concept in virtual memory. Occurs when a program attempts to access data or code that is in its address space but is not currently located in the system RAM. This can actually cause failure of the program to execute or inconsistency in data. Okay, let us move to the next slide. Working set and working set algorithms. Working set of a program is a collection of those pages in its virtual address space that have been recently referenced, that have been actually that have been not so far that have been actually used. These resources have not been not very far. They have not been very far used, but let's move to the next slide. The English is okay. The algorithms include list recently used, which is the algorithms which the CPU follows in order to execute programs. List recently used, not recently used, second chance. List recently used, the CPU will actually reason that let us actually try to utilize these resources which have been redundant and have been available but have not been utilized. Not recently used. In the CPU, in order to avoid overwhelming of a resource, it will actually resort to a not recently used resource, second chance, in order to give a program another chance for execution or for complete execution. Benefits of working set management: reduce page faults, as we have seen, efficiently memory management utilization, improve program execution. Demand paging and its benefits. As we have seen, we have already defined demand paging, so reduced memory usage. The program will only be allocated the resource which it requires. Improved performance, simplify memory management. Improve performance to allow other programs to access that portion of a resource, and the other programs access only what it requires. Page replacement policies. This is this policies which the CPU actually there are so like algorithms. We have first in, first out. The one that the first program to come in is the first one to be executed. Second chance gives a second chance to pages that have not been recently accessed before replacing them. Not recently used. I have explained this. Lastly, recently used. I have explained this as well. Thanks for watching. Subscribe to my YouTube channel. I'm still bringing more. I remain Rima Dennis, Mooney University. Thank you for listening. Bye bye.